Hey guys, welcome back to class. This is week 1, day 3, and we're going to be talking about naming ionic compounds. When it comes to naming ionic compounds, um, we have the fundamental compounds, which are pretty simple, not too many problems with it. But then we also have two exceptions that we have to consider. We have the polyatomic ions exception and then the transition metals exception. For transition metals, I will be testing you on not the difficult part of it, but the basics of it. I really need you guys to understand what transition metals are and why they're different and what they look like. I'm not necessarily going to test you on those guys. So let's just get right into the material. So what is an ionic compound? Is there a good spot for me? I'll just be super tiny up here. So what is an ionic compound? An ionic compound is when you have a metal and a non-metal that bond together. Right? For example, sodium and chlorine. If those come together and form a bond, they form sodium chloride. The reason why they form a bond is because sodium donates an electron to chlorine. Sodium loses an electron, so it becomes positively charged. We call that a cation. And chlorine gains an electron, so it becomes negatively charged. We call that an anion. How do you know if something is a metal or a non-metal? Well, the way you know is you look at the periodic table. If you are to the left of the stair-step line, which is right here. You kind of have to draw the stair-step line yourself or just see it yourself. It starts on the left side of boron and then it just looks like stairs going down. If you're to the left of the stair-step line, you're a metal with exceptions. Hydrogen, germanium, and antimony. These two are metalloids, which are different than metals and nonmetals. They have characteristics of both. It's like a mix of the two. We're not going to worry about those when we come to ionic compounds. And then hydrogen over here, it fits this group, this family. It fits in really well with this family with the exception that it is actually not a metal. It's a non-metal. And then if you're to the right of the stair-step line, you're a non-metal. Just like all these little blue guys right here. The exceptions are boron, silicon, arsenic, and tellurium. I don't think I said that one right. But those are exceptions. Those are metalloids. Metalloids aren't nonmetals. So we're not going to talk about those when we talk about ionic compounds. We're going to be talking about compounds for today. We're going to be talking about compounds that are made of one metal and one nonmetal. And if it has more than just two compounds, that's when we get into the polyatomic ion exception. But for this first portion of the class, there's only going to be two ions, or two elements. Let's move on. Now, naming ionic compounds. When you name the ionic compounds, wait, that is the same side. Oh. Okay, so if it's one of these, one of the elements in group 1A, ooh, yeah, okay. So group 1A has a positive 1 charge, if you remember our oxidation numbers. Group 2A has a positive 2 charge. Group 3A, these guys have positive 3 charge. And then let's do this. Group 4A has a positive or negative 4 charge. Group 5A has a negative 3 charge. Group 6A has a negative 2 charge. And group 7A has a negative 1 charge. These oxidation numbers you still need to remember. If you guys need a periodic table, you can print out this slide, or you can print out on the Schoology materials tab. I actually do have a periodic table there for you guys. But if you are part of group 1A, group 2A, or group 3A, then it's pretty easy to name those metals. These guys are actually also are mostly not going to be, I'm not going to be talking about those guys. So if you're one of these metals, then it's going to be easy to name these compounds. If you are not one of those metals, if you're in the center, we call those transition metals, right? The transition metals are the ones that are a lot more difficult to talk about or to be able to name and to write the formulas for, but we'll get into that. Now, naming fundamentals. You write the name of the metal first. So if I had something like NaCl, well, Na is the metal, The metal is always going to be the first one anyways. So you write the name of that first element. It should be sodium. Sodium. And then you move on to step 2. Step 2, you write the name of the nonmetal. Well, the nonmetal in this compound is chlorine. Chlorine is right here. You don't write the name, the actual name of the nonmetal. You write the "-ide version. This guy is not called chlorine. It's called chloride. The reason for it, chloride. The reason for changing the last part right there is to show that it has a negative charge. Either it's a -1, -2, or a -3 charge. But that's it. That's all you do. Step 1, you write the name of the metal. Step 2, you write the "-ide version of the nonmetal. The nonmetal will always be one of these 1, 2, 3, 4, 5, 6, 7, 8, 9. It'll be one of these 9 nonmetals. And the names are always going to be either carbide, nitride, phosphide, sulfide, oxide, fluoride, chloride, iodide, or hydride. Notice I didn't say carbonide or phosphorus-ide or hydrogen-ide or chlorine-ide or oxygen-ide, right? The "-ide" versions actually sound good, so they're actually pretty easy to memorize. So now that we got into that, let's get into some practice. I'll do the first one with you guys. You write the name of the metal first, aluminum. Aluminum. And then the non-metal second, but you have to write the "-ide" version of the non-metal. Right, so this is aluminum, chloride, and that's your answer. Now, you guys go ahead and pause the video and move on. Or pause the video, try it yourself, and then play the video, see if you're right. The correct answers are aluminum chloride, lithium nitride, magnesium iodide, calcium oxide, and sodium sulfide. Let's get a little bit more practice. But now instead of giving you the actual names of the metals or the compound or the elements, I'm giving you the symbols. So Be, I'll do the first one with you guys. Be is beryllium. N is nitrogen. Beryllium is the metal, nitrogen is the non-metal. So this is going to be called beryllium nitride. Okay, now I want you guys to go ahead and pause the video and try the rest yourself. And I'm going to go over the answers. So the answers are beryllium nitride, sodium oxide, potassium phosphide, aluminum nitride, and magnesium chloride. Those are your answers. Double check them. Any questions, make sure to send me some emails. I will answer all your emails. I'll be sitting at this computer pretty much all day waiting for you guys to ask me questions. All right, polyatomic ion exception. Actually, there should not be a space here. Yeah, this is the way to spell it. There shouldn't be a space there. I'm not fixing it though. Okay, if a polyatomic ion is present, use its formal name instead. So how do you know if a polyatomic ion is present? Great question. You actually look at this list. You have to kind of memorize this list. It's easier on you if you memorize this list. You really don't have to because I did give you a reference sheet with these and more polyatomic ions. What you do need to be able to do is recognize that there is a polyatomic ion. Recognize that you need to use that reference sheet in order to name these. So I'm going to go over the names of these just so you hear them out loud. NH4 is ammonium. NO3 is nitrate. OH is hydroxide. PO4 is phosphate. SO4 sulfate. CO3 carbonate. C2H3O2 acetate. That's vinegar. ClO3 chlorate. And these all have charges. When we talk about transition metals, you're going to have to know the charges. Until then, I wouldn't worry about it just yet, not for these next couple slides. Just work on recognizing that there's a transition metal. And I'll give you a hint. A good way to recognize that there's a polyatomic ion. A good way to recognize that there's a polyatomic ion is that there's going to be more than 2 elements in the compound. And typically that'll show you that there's a polyatomic ion. So which of these is the polyatomic ion? It is right here, NO3. So let's go back and look at what NO3 is called. NO3. Let's try the highlighter. NO3. Oh, no, highlighter doesn't work. Does it? Oh, here. NO3 is right here. It's called nitrate. So instead of the rule with polyatomic ions, you don't change the name to ide, right? It's not called nitride. Nitride is something completely different. Nitride is this, N minus 3. So if you were to call this sodium nitride, you would be incorrect because sodium nitride is Na3N. So you would be completely incorrect with that. What you should be calling this is sodium nitrate. Sodium nitrate. And now I will, instead of, yeah, I'll just click through it. Here's the answer. Sodium nitrate. Now I want you guys to pause the video and try the other ones. And now I'm going to go over the answers. So you have calcium sulfate, ammonium oxide, magnesium phosphate, and ammonium nitrate. There's 2 polyatomic ions here. Here's your polyatomic ion for ammonium, and here's your polyatomic ion for nitrate. If you guys want, you can put, I won't mark you off for putting parentheses around polyatomic ions. You typically, if there's only one of that ion, you're not supposed to write the parentheses. I won't mark off for it. I want you guys to be able to recognize these polyatomic ions, because the thing about polyatomic ions is that they stay grouped. These subscripts never change. This will never be N2O3 because that's not nitrate anymore. Right? If you have more than one nitrate here, you'd put the 2 on the outside of the parentheses. That's 2 nitrates. Or you could have 7 nitrates, right? You just change that part. All right, moving on. Now we're going to get into transition metals. Remember, I'm not testing you on this part. This first slide I could test you on. Everything after this first slide, I'm not going to put on the test. But I do want you to be able to recognize. So if the metal is a transition metal, identify the charge with the Roman numeral. And the reason for this is because transition metals, the reason why we call them transition metals is because they actually can have multiple charges. They could have a +1 charge or a +2 charge, a +7 charge. They can have some ridiculous charges. For example, copper +1 or copper +2, right? The copper can form 2 different ions, and the way we show that is with the Roman numeral right here, copper 1 and copper 2. Something to keep in mind is that the charge will always be positive. So yes, you're representing it with the Roman numeral. Yes, we don't know what the charge actually is, but it's still a metal. Metals form positive charges. And they act completely different. For example, if you were to have copper 2 dissolved in water, it'll be this really pretty bright blue solution. If you have copper 1 dissolved in water, it'll be this murky brown gray solution. Determining the Roman numerals for transition metals. So there's 2 ways to do this. You're going to have to know both ways. Sometimes option 1 is better. Sometimes option 2 is better. So I'm going to show you both cases. So here's an example. Example 1. Let's say I have this molecule, tin phosphate. Well, if we look, we know tin is going to be one of the transition metals. Actually, if you look at the periodic table, tin is right over... Tin is actually right over here. It's not in the transition metal section, but it is one of our metals that are in this area. Remember, these metals right here are going to be are going to be the transition, work just the same as transition metals as well. So tin, where are we? So we have tin phosphate. It's not an oxidation number we just know or memorize. So option number 1. It's called the reverse crisscross method. You take this number and you give it to tin. You take this number and you give it to phosphate. Right? We don't know tin, but we do know phosphate has a -3 charge. That's this 3 goes up here. This 4 goes up here. So now using this method, we know tin should have a +4 charge. Tin 4 phosphate. And the reason why we know that is just because there's a 4 right here. There's this 4 goes here. Option 2. Now this is the second method. This is the more visual method. I actually really enjoy this method. We know there's 3 tins and we know there's 4 phosphates. So you just draw 3 circles to represent tin and 4 circles to represent phosphates. We know there's 4 of those. We also know, if we use our reference sheet, that phosphate has a -3 charge. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In total, phosphate is going to be giving us a -12 charge. these molecules should always be balanced. So whatever tin is, it needs to balance out this negative 12 charge. In order to balance out the negative 12 charge, well, you would need a positive 12 charge. In order to get a positive 12 charge, you would need 4, 8, 12, right? You would need each charge to be a positive 4. You would need this to be positive 4, positive 4, positive 4. And if each tin molecule had a positive 4 charge, then these two would balance. So that's also how we can know that tin 4 phosphate, right? That the Roman numeral should be 4. Now that's an example where example 1 is actually easier. Here's an example where option 2 is actually easier. Right, let's say I have tin, or this isn't tin anymore. Let's say I have iron sulfate. Well, if you use the reverse crisscross method, you'd have sulfate -1 and iron +1, right? Because these would have the subscripts of 1. Now that's not actually the case, because if we look at our reference sheet, sulfate has a, where's the reference sheet? Sulfate has a -2 charge. So why would that reverse crisscross method not work out? And the reason why it doesn't work out, let's go back to the slide. The reason why it doesn't work out is because these numbers actually got reduced. So we don't know the charge of iron, but we do know the charge of sulfate. This 4 doesn't go up here. This is where a lot of people make mistakes. They take this 4 and they put it up here and say it's iron 4. No, it cannot be iron 4. This is a polyatomic ion, so you would take this one out here, right? And it's still not iron 1 because it got reduced. The 2 would go here. You see that that does not match up, so that's why the reverse crisscross method in this case just doesn't work. So I wouldn't even use the reverse crisscross method for this example. I would use this method, option 2. And the reason why I would use this method is because you got to draw. Well, first of all, you want to draw your circles. One circle to represent 1 iron, and another circle to represent 1 sulfate. We looked at that table and we did see that sulfate had a -2 charge. Well, in order for that to balance, that 1 iron needs to have a +2 charge. And we can see that it balances, right? And it's going to be called iron 2 sulfate because iron has this +2 charge, which balances the -2 charge of sulfate. So now we're going to practice this method, right? Iron and chloride, or iron and chlorine. So now, I'll go over the answers with you guys. So for here, let's use the reverse crisscross method. Iron 3 and chlorine with a -1 charge. I know this is going to work out because chlorine does actually have a -1 charge. So I'm fine. Now it's called iron. Ooh, not that. Iron. Well, I can't write. I'm just gonna click and show you guys the words. Iron 3 chloride. Now I'm going to go over the next one with you guys. The next one is option 2. This is chromium and this is oxygen. If I were to try the reverse crisscross method, right, it would be oxygen with a -1 charge and chromium with a +1 charge. I know this is wrong because oxygen actually has a positive or a -2 charge, not a -1 charge. So reverse crisscross method won't work here. What you need to use is the visual method. I don't know the charge of chromium, but I do know oxygen has a -2 charge. In order for chromium to balance out this 1 oxygen, this chromium needs to have a +2 charge. So I know it's called chromium 2 oxide. Right, with these transition metals, don't forget you're still writing the "-ide" version of the non-metal. Now I want you guys to pause the video and try the other 3. And here are your answers. Manganese. You use the crisscross method. Oxygen does have a -2 charge in actuality, so that means manganese has that 7 charge. So it's manganese 7 oxide. Chromium nitride. Chromium has a a 1 and nitrogen has a 1. If you tried the reverse crisscross method, you'd end up with nitrogen having a negative 1 charge. That's not correct. Nitrogen should have a negative 3 charge. So you end up with, we know the reverse crisscross method doesn't work, right? So you would have to rely on the other method. Knowing that nitrogen has a negative 3 charge, chromium should have a positive 3 charge to cancel that out. So it's chromium 3 nitride. And then the next one, there's a mistake here. Right, there should be a subscript 1 here. I'm sorry if that confused some of you guys. Now pause the video and try it again if it's a mistake. Okay, so this is actually called silver 1 sulfide because sulfur has a negative 2 charge if you look at the oxidation numbers on the periodic table. So you just use the reverse crisscross method. This 2 goes here, negative 2, and we know that works. And so that means silver would have to have a positive 1 charge. And there's 2 silvers here, so those 2 positive 1 charges would cancel out the 1 negative 2 charge from sulfur. All right, so now we're going to do some mixed practice. I want you guys to practice without knowing exactly which method to follow. Try and figure out what method you need to follow to answer these. I'm going to give you guys a couple seconds, and then I'm going to go over the answers. So pause the video. Okay, magnesium and chlorine. Well, these are both metals. This is a metal and this is a non-metal, so it's ionic. And then on top of that, we know the charge of magnesium and we know the charge of chlorine. The charge of magnesium is +2. The charge of chlorine is -1. I have 2 chlorines here though. So times 2, that gives me a total of a -2 charge. This +2 cancels this -2, so it works out perfectly. So this is called magnesium chloride. The next example, I see a polyatomic ion and I see another polyatomic ion. So I'm just going to use the names of these polyatomic ions. And this is called ammonium and phosphate. Ammonium phosphate. And then the third example, I see a metal here, a transition metal. And then, so I don't know this charge. And I question mark. However, I see a polyatomic ion here. And I do know this charge. This hydroxide has a -1 charge. But there's 2 of those. So this hydroxide molecule is going to give me a total of a -2 charge. In order for the nickel to cancel that or to balance that out, nickel should have a +2 charge. So I'm going to use Roman numeral 2 to represent that. And we're going to call it nickel 2 hydroxide. And that is the whole video. Bye guys, have a great day.